Hello. This study is to investigate the long-term trend of an important boundary in the upper atmosphere, the mesopause. We are utilizing 30 years of sodium LiDAR nighttime measurement to conduct this study. In this paper, we will review the long-term trend of the mesopause height and the mesopause temperature, and also answer the question such as, are there uh, differences between the summer mesopause trend and the trend of a winter mesopause? And also, does the trend behave differently during different part uh, of the time frame? And what is the effect of the solar activity on these trend results? The data we're using consists of a LiDAR measurement in Colorado and Utah. The Colorado part covers the period between 1990 and 2010, and the Utah database covers the period between 2010 until present. The These pictures shows the LiDAR beams of the sodium LiDAR uh, in Utah and Colorado. It's the same system. Uh, it has the capability of nighttime and daytime temperature and wind measurements, and also the sodium density. The trend in the lower atmosphere has been well established. For example, this plot shows the temperature anomaly uh, between 1958 to 2012 in the stratosphere, which is the top plot, and the temperature trends in the troposphere and surface. Uh, the two trends behave differently because the stratosphere's trend is mostly decided by the ozone, and we know that the ozone has been decreasing over the past over the most part of the half century. Uh, but it is noticed that after 1995, the stratosphere's ozone has been recovered, and you can see the trend after 1995 become insignificant. However, the the troposphere and surface trend has been pretty consistent due to the increasing greenhouse gas. In the upper atmosphere, um, we the focus of this study is the mesopause, which is the coldest region in the in the atmosphere, and also it is the boundary between the mesosphere and the thermosphere. Uh, there's been recorded there's been reported that the uh, dropping of a radio wave reflection height, which is an indication of the shrinking of a neutral atmosphere. So today we will look at the neutral temperature change of the mesopause and also the height change over the 30 years. If we look at the thermal balance in the MLT, mesosphere and lower thermosphere, the major sources are the absorption of of the UV spectrum in the solar radiation, chemical heating due to exothermic reaction, also induced by the solar radiation, mostly associated with the solar radiation, and the adiabatic heating and cooling due to the upward flow and the downward flow of the atmosphere, and also more importantly, the radiative cooling of the CO2 in the MLT region. This plot shows the 30 years of LiDAR measurement of of the mesopause temperature, which is the top part, and the mesopause height change over the 30 years period, and you can clearly see the mesopause height identifies two groups of mesopause. One is the mesopause at lower altitude, which is mostly induced by by the adiabatic process. Mostly happened in the summer month, and also the the radiative high mesopause, which is mostly happened in the winter months. The high mesopause occurs around 100 kilometer, and the low mesopause, dynamic mesopause, occurs mostly around 84, 85 kilometer. And if we fit both the height and temperature with this fitting function, m sub o is the initial value, m1 is the linear trend, and m2 is the response to the solar activity, and we can derive the linear trend term and the solar radiation term fairly easily. This slide shows the mesopause the day of year of mesopause for low mesopause and high mesopause. Again, the low mesopause is the dynamic mesopause, and high mesopause is mostly the radiative mesopause due to radiative cooling. And overall, there are about 388 nights of low mesopause, mostly in summer, and 824 nights of high mesopause in the fall and winter month. If we fit these mesopause height and mesopause temperature separately for high mesopause and low mesopause, we get these results, especially the linear trend result. For example, in this slide, the top figure shows the initial value of mesopause height, high mesopause height, which is about 102 kilometer, and its linear trend is a negative 450 meter per decade, which indicates the dropping of high mesopause height 450 meter per decade. For the high mesopause temperature trend, it still has overall cooling trend of 2.5 Kelvin per decade, and it has some positive response for solar activity. The red dashed line represent the solar daily F10.7 radiation. Look at the results for low mesopause. The initial height is about 87.5 kilometer. It also decreasing. So it also shows the decreasing of summer low mesopause height, but the dropping speed is considerably slower than the high mesopause. However, if we look at the uncertainty of the fitting, this result is in the same order of magnitude of fitting uncertainty. So overall, it is statistically insignificant. The temperature trend for low mesopause is similar to that of high mesopause, which is about 2.3 Kelvin per decade. Still overall cooling trend if we include all the data between of these 30 years of measurements. This table lists the overall results of this investigation. The most important part is the linear trend for a mesopause temperature. For high mesopause, like I said, it's about 2.5 Kelvin per decade with the statistical uncertainty of 0.4 Kelvin. And the low mesopause is similar, cooling of 2.3 Kelvin per decade with the uncertainty of 0.5 Kelvin. The solar response is also similar, although from statistic point of view, the solar response term is insignificant. So this is about temperature. For the mesopause height, if we include the data from 1990 to 2020, the overall dropping rate is about 450 meter per decade for high mesopause, and 130 meter per decade for low mesopause. Like I said, once we include the uncertainty, the low mesopause dropping rate is actually insignificant, statistically insignificant. And the interesting part is the high mesopause height doesn't seem to be affected by this solar activity, whereas the low mesopause height have some response to the solar activity, which is interesting. However, if we separate the 30-year database into two parts and look at the trend result after 2000, between 2000 and 2018, but now we have data until 2020, the results are similar. Both of the temperature trend for high mesopause and low mesopause become statistically insignificant. So there's no apparent temperature trend of mesopause after 2000 of mesopause. But the height trend, the height of mesopause is still decreasing fairly consistently, 470 meter per decade, with slightly larger uncertainty because we have less data. And again, the height trend of low mesopause is still statistically insignificant. And we also look at the model simulation. We use the most recent BICOMAX study to compare the results. So there are two colors. Black color represent the low mesopause. So this black solid line represent the summer average temperature between 1972 and 1976. And the dash line, the black dash line, represent the low mesopause average temperature. Average temperature profile of summer in 2001, between 2001 and 2005. And if we look at the difference between these two black profiles, we can calculate the low mesopause trend, temperature trend is about 0.41 Kelvin per decade is still a cooling trend, but much less than the LiDAR data shows. The height trend, the low mesopause height trend, is negative 230 meter per decade, which is in a similar order of magnitude of what LiDAR reviewed. So this is for the low mesopause. But if we look at the high mesopause, in the model simulation, the cooling trend is still, the cooling trend of the mesopause temperature is negative 0.75 Kelvin per decade. Again, much less than the LiDAR high mesopause trend. The dropping rate is 179 meter per decade, which is considerably slower than the LiDAR measurement shows. Again, so these model results is for the location near Utah and Colorado. So overall, the magnitude of the trend result in this model simulation are similar to the LiDAR LiDAR measurement review, but the cooling trend is less, and the dropping of mesopause height is also less than the LiDAR results. Overall, the LiDAR 30 years measurement, 30 years of measurement is the longest database in MLT, and it's still continuing. The mid-latitude mesopause is cooling at the rate of about 2 Kelvin per decade since 1990, but the cooling trend cooling trend of mesopause temperature become statistically insignificant after 2000. The height of high mesopause, which is the radiative mesopause, is dropping at a speed of 450 meter per decade, and has been very consistent. And the cooling, the trend of low mesopause, which is dynamic mesopause decided by the adiabatic process, is statistically insignificant. And the last conclusion: the low mesopause has stronger solar response than the high mesopause. That's it. Thank you.